Well, hello everybody. Welcome to lesson 3-3, all about rate of change and slope. So if you take a look over here on the right-hand side, I've listed all of the synonyms that I can think of, and I'm sure there's still more, for slope or rate of change. So anytime you hear them talking about slope, they're talking about rate of change. We're also talking about rise over run. And then you see I have triangle y over triangle x. Well, triangle in math is just a fancy symbol for change. So I like this one the best because that says, hey, what's your change in y? And divide that by your change in x. And for a lot of these, when we're talking about changing, we're thinking about one of our favorite operations, and that's subtraction. Okay, so we're going to look at some different graphs. Again, we're still looking at linear functions, and we're going to see how are things changing, all right? And we see a lot of time in a lot of our graphs here. So how is something changing over time? So again, the top part there, good examples for you. If my examples aren't making any sense, but in the meantime, let's take a look at what we have here. Okay. So we've got a graph here at the right that shows us life expectancy for men and women. Apparently women are living longer than men are expected to, at least, so good news for some of us. Not so good news for the rest of us. Anyway, so it says find the rate of change for women from 2000 to 2025, and then again from 2025 to 2050. So, okay, so we can do that. So, again, think change in y over change in x. So change in y means how are the y values, or how is the age changing? So you can think of the change in age over the change in years, if that helps you. All right. So let's look here. So again, here's our two that we're going to use. So our change in age went from 80 to 84, so that would be a change of 4. Our change in years went from 2000 to 2025, so that's a change of 25. There you go. So there's your slope. Now, if you'd like to make this, right, 4/25 of a year, right, of a year. If you'd like to make this into a decimal, we can do that. We could say, I think it's about 0.16, again, of a year, that their life expectancy is increasing every year. So their age increases by 0.16 years for every 1 year of time that goes by, right? That's what that means. We can also find the rate of change. Again, we're still on women from 2025 to 2050. Again, so now I'm looking at 84 to 87. That's a change of 3. Same thing from 2025 to 2050. That's also a change in 25 years. All right, so this one not changing as fast, right? This gives us 0.12 when we divide. So again, our life expectancy is increasing by 0.12 years for every 1 year that goes by of time. All right, we can do the same thing for the guys here. I'll change colors. So we're going to do the first one from 2000, so right here, 74. All right, to right there in 2025. So maybe some of you are noticing that, hey, even though they're different ages, it's still a change of 4 years over 25 years of time, which still gives us that same 0.16. And then the same thing holds true, really, when we look at the next 25-year span. From 2025 to 2050, their age goes from 78 to 81. So, again, that's a change of 3 years out of 25 years. So, again, that's 0.12 years. So their life expectancy, interestingly enough, is increasing at the same rate of change for both men and women, just different ages. So explain the meaning of your results for 1 and 2. Well, both men and women increase their life expectancy at the same rates, right? At the same rates. If you look closely at those lines, right, they have something special about them, but we'll talk about that later. So there's your answer for C. I'm not gonna. That's too much to write down. Letter D. What patterns do you see in the increase with each 25-year period? Well, while the life expectancy increases, it doesn't increase at a constant rate. So, in other words, if you think about it, the first 25 years we increased by this 0.16 number. The second 25 years we increased at 0.12. So pretty close, but not a constant rate for the entire graph that we see. Then it says, make a prediction for the life expectancy for 2050 to 2075. Explain how you arrived at your prediction. So in other words, if our graph kept going, what would we predict 2075? Right. So if we had 2075 out here, right? So here's 2075. Does this line, maybe go like this? Does this line maybe go like I don't know, here? This is a really terrible line. But what age are they at? So, if you look and say on, women, okay, they went from 80 to 84 for the first 25 years. So that went up by 4. Then they went from 84 to 87. That went up by 3. So maybe in the next 25 years, maybe they're only going to go up by, I don't know, 2. So maybe we'll say, women will end up being at 89. And for guys, maybe we'll have that same plus 2. Maybe guys will end up at 83. And this is our 2075 predictions. Sounds pretty sweet. Okay, so I think we've tackled this page. That looks good. Yeah, I think it looks great. Okay, let's move on to page number 2. Kapow! Here we go. Okay, so on this page, we're going to be doing a little bit. Actually, I think this page is a little bit easier. Again, if you look up top here, you see some fancy stuff. So here's rise over run. Now we do have an awesome formula for slope, right? And that is right here. And you'll see they've got this equals m on here, right? That's another synonym you could put. So slope is little letter of the alphabet m. Okay? And we can find slope if we're given ordered pairs, right, from like a graph, right? We can figure out slope pretty easily using that y2 minus y1 divided by x2 minus x1 formula. So here's how it works. I'm not going to do all of these, but I'll do 1, 4, and 7. The process is really the same. So I'll give you the answers for the other ones, but we really don't need to do all these because it literally is just this easy. So take a look at what we do here. So the first thing I want to do on number 1 is I'll say, hey, this is my first ordered pair. Here's my second ordered pair, right? And then we know there's an x and a y in each ordered pair. Hopefully we know that. So because 4 and 9 are in my first ordered pair, I'm just going to call them x1 and y1. Because 1, 6 was my second ordered pair, I'm going to call 1 and 6 x2 and y2. And now we can use our handy, right? So it's y2 minus y1 over x2 minus x1. Okay, so plug your numbers in where they go. So y2 minus y1. So that's 6 minus 9. And that's going to be over x2, 1, minus x1, which is 4. So be careful with your subtraction here. 6 minus 9, negative 3. 1 minus 4, also negative 3. So slope, we're cool if it's a fraction. If it simplifies like this one does, though, let's go ahead and do that. So this one has a slope of 1. Again, slope, just a positive number. I've actually lied to you. I'm going to do number 2 because anything with negatives and slope can get very, very tricky. So here's x1, here's y1, here's x2, here's y2, right? That's always a good first step. So y2 minus y1, notice what just happened there, x2 minus x1. So we're going to get double negatives all day long if my first ordered pair has some negative numbers in it like this one does. So be careful. This really means plus, plus. This means plus, plus. So -5 plus 1, just -4. -2 plus 4 is just +2. Again, simplify. We get -2. There's a bear trap on number 3, so let's slide over here. Again, I lied to you even more. We're going to do number 3. Okay, so same thing. x1, y1, x2, y2. So y2 minus y1, x2 minus x1. Okay. Here we go. -5 minus a -1. Again, think plus, plus. So that should be -4. Again, this turns into plus, plus. -4 plus 4 is 0. So while we can have a slope of 0, if you type this into your calculator, what do you get? It's supposed to go that way. There you go. You get an undefined. So this can't happen, right? This leads me into another thing that I will tell you, which is we have 4 kinds of slope, right? I have slope can be a positive number, slope can be a negative number, and this is what the lines would look like on a graph, right? If our line increases, like this one here, it's positive. If it looks like the second one, it's negative. If we have a line that is a horizontal line, that has a slope of 0. And if we get a vertical line, all right, that means we have undefined slope, right? That means our graph is changing so quickly we can't calculate it, so it's undefined. And that looks mathematically like this down here. We're trying to divide by 0, which can't happen. Okay, so here's your 4 kinds of slope. Again, you're learning all sorts of fun stuff here. Positive slope, negative slope look like those kinds of lines on a graph. Horizontal lines have 0 slope, and that's okay, right? And then we have undefined. So if you want to try these other ones, like magic, I'm going to make those answers appear here in just 1 second. If you don't want to try them, well then too bad. I'm going to put the answers up here in just a second anyway, all right? So give them a shot. Pause the video if you want to. Okay, so we're back. Ba-boom, there's all your fun answers there. And this now leads me into the second thing that we can do with slope. Sometimes if we're given particular ordered pairs, but maybe one of them, one of the x or y values is left out, we can figure out what it should be if they tell us what the slope is. Remember, we can just use our awesome formula that we enjoy so much, right, which is the slope is equal to y2 minus y1 over x2 minus x1, right? Anytime we have 1, 2, 3, there's 4, 5 actually variables in that equation, and in these problems we're going to know 4 things, so we can always figure it out. And I'll show you a couple different strategies to do that. So let's take a look. I don't know, let's take a look at number 10 first, right? Let's do this one. So if I'm going to set up number 10, I'm going to use everything right here, and I'm going to make it look like this. So I'm going to say I want 1 to be equal, because that's what m is, to y2 minus y1. So y2, -2, minus y1, 8, and that's over x2, in this case is r, whatever that is, minus 6. Okay. If you would like to do some cross multiplying and solving, if I do this, you should now maybe have an idea of how to solve this equation. Again, cross multiply and solve. So cross multiply here, right? Cross multiply here. So this turns into 1 times this r minus 6. This turns into 1 times -2 minus 8. Now my formula's in the way, but that's okay. So this, we can say we distributed, but it doesn't change anything. It's still r minus 6. equals, again, we could say we distributed a positive 1, but it doesn't change anything. It's still negative 2 minus 8, which is just negative 10. Then I could add 6 to both sides. And all of a sudden we know r is equal to negative 10 plus 6, which is negative 4. Right, and that's our answer. So here r would equal negative 4. So that's one way that we can solve these. We can also solve them with just some good old-fashioned common sense too. And I'll show you that method here on number 11. So let me, let's hop over here. And I'm still going to set it up the same way. So I'm still going to say, hey, 3/4 is equal to, and then let's go through the y2, in this case r. y1 is negative 3. And this one's over x2, 7, minus x1, negative 1. Okay, so think about what we want to. Now, I've got some double negatives in here, so I'm going to simplify this a little bit to say this is really r plus 1. And 7 minus, right, 7 minus 1 really turns into 8. All right. So now look at what we have. Again, if you would like to cross multiply and solve, you can do that. Right? You can say, hey, 4 times r plus 1 is equal to 8 times 3. I am A-okay with that. Or you can try to make an equivalent fraction here. Right? You can say, hey, what could I do to make an equivalent fraction? And maybe this one isn't the best example to do that with, but it would still work. All right. But maybe I'm thinking you might like me to just cross multiply and solve. So let's not confuse anybody. So this was r plus 1. There you go. So this should turn into 4r plus 4. And this would turn into 24. Let's do subtract 4 from both sides. So 4r equals 20. And divide by 4. And r is equal to 5. Does that sound okay? You guys all right with that? Yeah, I think that's good. Okay. Again, so if you think about here, let's use this. If we knew we wanted to make an equivalent fraction from this right here, and 3/4, well, if you make an equivalent fraction to 3/4, but now your denominator is this 8, right? What would 3/4 be in eighths, right? So if you multiplied this by 2, you'd get 8. If you multiplied this by 2, you would get 6. So now I know r plus 1 has to turn into 6, and then it becomes easy to say, oh, well, r's got to be 5 because 5 plus 1 is 6. So that's how we can use a little bit of common sense to still come up with the same answer on that. And so I've drawn everywhere on here, but I think just those couple problems hopefully give us an indication of that. If you want to give 12 and 15 a shot, I can tell you that I believe number 12 turns into that, and number 15 turns into a horrible fraction, 23/3. Okay, so if you want to try those two, you can. If not, there's tons of practice on the next 2 pages, so I'm not overly concerned with that. But there's the a whole bunch of stuff with slope. So we can find slope from a graph. We can find slope from ordered pairs. We can find a missing point if they tell us what slope they want. So a lot of things we can do there. The next 2 pages are all on you. Again, don't forget the solutions are online. Work through as many as you need to until you get the hang of it. If you have questions, ask me. Other than that, you've been a phenomenal audience today. Thanks for your attention and good questions. So have a great day, everybody. I'll see you.